Good evening, all. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I welcome you all to this very special endeavor which has been started on the behalf of StudyIQ IAS English for you all, especially to those aspirants who face difficulty with regards to analyzing the maps, with regards to analyzing the most potent tool in learning the geographical discipline, that is the analysis of maps per se. In this sessions, we will be focusing on three things. In this session, we will be focusing on the analysis of maps per se, and through these sessions, we will be able to get three things. Sorry, there was some delay in the audio lag, so just rectifying that. So in this sessions, we'll be focusing primarily on three things per se, guys. So I will be using maps for not only analyzing the map, for not only analyzing the world, but I will make sure that I will help you all in understanding roughly 50 to 60% of your geography GS discourse. And using this knowledge, using this content, we will try to cover up roughly 60 to 70% of your basic GS discourse, and also we will try to use these concepts for learning some of the advanced level concepts too. So the first thing that I wish to achieve with you all is that this curriculum which I will be doing with you all, today being the 12th session, today being the 12th lecture of this curriculum. So using this curriculum, which being a continuing curriculum, I wish to present you all a medium through which you can get roughly 50 to 60% of your geography GS discourse. And second thing which I wish to achieve with you all is utilitarian value of maps, wherein using maps we will try to cover roughly 15 to 20% of your prelims discourse, and roughly you will be able to score 20 to 30 marks using the content which I'll be showcasing you on the board. And in mains, you will be easily able to score 100 to 200 marks. And if essay comes in your purview, guys, we will be moving even forward. You will be having roughly 300 to 400 marks coverage right here from this content. So it's my endeavor that I give you the best possible content so that you can have the maximum amount of marks in your mains and the prelims too. So, and the third thing which I wish to do with this sessions is I wish that each and every one of you start appreciating this discipline. Why? Because geography as a discipline is interconnected with your life and my life on this planet. Okay, geography has got to do everything from your lifestyle, from your experience on this earth, the future of the planet. So up till now we have discussed n number of things with regards to this discipline which affect your life and my life. So my endeavor will be that ultimately I will make each and every one of you to fall in love with geography and to like this discipline. Okay, but I will make sure that you don't fall deeply in love with this discipline, because if you do so, then you will end up coaching this discipline like me. So I don't want that each one and every one of you should fall deeply in love, but yes, you appreciate this discipline on a wholesome level. Okay, so before I begin, the typical flow of the classes is like this. So in any day's class, I tend to revise whatever we did in the previous class for roughly 5 to 10 minutes. Then I introduce you to new concepts. Once I introduce you to new concepts, then I use the practical applicability of the concepts on the maps. And I also give certain homework. I also expect you all to do something on behalf of me, and that is how we continue. So today being the 12th session, today being the continuum of whatever we did in the previous classes, so we'll march continually from here forward. Okay, so before I move ahead, I will like to quickly reintroduce myself. My name is Pritesh Maturkar. Okay, you can all reach out to me on a Telegram channel called as Geography by Pritesh Maturkar. And for joining this channel, you can just do a global Telegram search at Geography by Pritesh. So if you just do this at Geography by Pritesh, you will be able to easily reach out to me on this channel, where I keep on posting the relevant tidbits of this discipline, either in links form, either in PDF forms, or sometimes in infographics form. Because guys, it's all about appreciating the discipline. If you appreciate the discipline wholesomely, you will be easily able to grasp the things. And as I promised you guys, in every lecture I will try to paint a picture for you all of what we did in the previous session. So today, the first picture which I wish to see, which I wish to that every one of you should see, is a very picturesque location of the mangroves of New Zealand. So if I'm showcasing you the East Coast of New Zealand per se, so I'm just doing a live search so that you have one of the most beautiful images of New Zealand per se. Okay, so So the image which you are seeing just behind me is a very beautiful image of the East Coast of New Zealand. If you can see over here, so this is one of the river which is meeting the sea, and if you see this dense evergreen temperate vegetation, this is very unique to only certain locations of the world, and New Zealand is where you have this location where this rainforest do exist in its most pristine form. They are very untouched and they are very beautiful. So it's my endeavor, guys, that I wish that each and every one of you appreciate, that each one of you imbibe the beauty of the planet in your blood, because that is how you will start appreciating this discipline, and how each and every one of you will start getting comfortable with me. And that is very important, that each one of you gets comfortable with me, guys. Okay, so before any ado, let's move ahead. So in the previous classes, I introduced you to how climate change is different at different places and how it manifests globally. So today onwards, I will be discussing the last part of climatology, which I think is important for our coverage of the maps. Then and thereafter, I will be moving to discussion of the land surface of Earth. Okay, so today being the last session where I discuss the tidbits of climatology with you all, which I think are important from the maps perspective, which I think is important from a perspective which will require your understanding of the planet. And that last thing that I'm discussing after climate change with regard to climatology is a thing called as, again guys, it's a little bit of technical term, but it's a thing called as moisture, precipitation and humidity. Okay, so I'm discussing three things with you all today. So I'm discussing moisture, I'm discussing precipitation, and I'm discussing humidity. So these three things I will be discussing with you all today. These three things being very important. So why these three things are important? Because the rainfall patterns globally, the amount of moisture in the atmosphere, and whether you will have rainfall or whether you will have desert topography is heavily dependent on these three parameters, and how these three parameters are linked to the aridity of a place, and the whether the place is warm, wet, humid or dry. So whether how are these parameters are linked to the aridity of the place, and in general how aridity is linked to topography. So how topography and aridity, they go hand in hand together, that is what we will analyze in these lectures. So I just want every one of you to pay close attention to this, because after this I'll be moving into the discussion of the lithosphere of Earth per se, which I think is important for your coverage of maps. Okay, so let's move ahead with the discussion of this. So moisture, precipitation and humidity. Guys, what do you mean by moisture? What do you mean by water vapor content in the atmosphere? Okay, you all know that Earth receives sunlight Earth receives sunlight as its primary insolation source. So you have what? You have sun's rays striking the surface of Earth. The sun's rays will strike the earth, they will absorb some of the heat, the land surface will absorb some of the heat, and then it will reflect it back, and then it will reflect it back. So as it will reflect it back, what will happen? You will have the greenhouse gases in the atmosphere. These greenhouse gases will do what? These greenhouse gases will trap the heat and they will warm up the atmosphere. So you have this heat trapped in the atmosphere, which will again result into what? Which will again result into maintenance of average ambient temperature on Earth. But mind you guys, whenever we have moisture content, whenever we have humidity or precipitation, this heat trap is of course responsible for that, but you have one more thing which results in the global distribution of temperature, global distribution of precipitation around the earth, and that thing is closely linked to how much insolation you get at various latitudes. And that we have already did, that the equatorial locations will have what? They will have the maximum water vapor content. Why? Because on the equator the sun's rays will fall perpendicularly. So because of this, as more and more land is heated, more and more radiation is lost, so more and more air will rise up, leading to what? Intense vertical thermal convection. And as the air will rise, it will cool down to form clouds. So on equatorial regions you will have the highest water vapor content anywhere on the earth. So now if we go to equatorial regions, if we go to Singapore, if we go to the Congo rainforest, if we go to the Amazon basin, so there you will have water vapor content exceeding 4 to 5%. And mind you guys, these water vapor content will not be constant everywhere. Water vapor content will vary from places to places, from latitudes to latitudes. Now one very simple question comes as to how should we measure the water vapor content, as to how should we measure the humidity of a place. Okay, so if I'm asking you to measure the moisture content or the humidity of a place, you can answer me, sir, very simply, that what is the moisture in the air? Moisture is basically the total water vapor content, the total water vapor content in the air, the total water vapor content in the air. Okay, so this is the total moisture of air. Okay, very crude definition. Okay, but now if I'm asking you to give me an analysis of humidity as to how much the air is saturated, so you can say to me, sir, if I'm measuring humidity, so you can measure humidity in 2 to 3 forms. You can measure humidity in as a absolute index, where you compare the humidity on gram per volume basis. So if I'm asking you, let's say absolute humidity, so absolute humidity you can express either in gram per cc, so the amount of moisture present in the air upon the volume of air, or if I'm asking you specific humidity, so specific humidity can be reasoned as the amount of moisture in the air upon the total moisture content in the atmosphere. So you can have gram per gram, which can get negated, so specific humidity will have no index. But guys, if I truly want to measure whether you will have rainfall or whether you will have rain in any part of the world, how can you express this? If any one of you has seen the movie called as Swadesh, okay, IAS aspirant should see that movie because it's a very motivating movie. So if you see a movie called as Swadesh, so there is a very famous dialogue that Shah Rukh Khan says that I'll launch such satellites into the space which measure whether you will have clouds, whether you will have precipitation, and a person in the village just look up at the sky and says, oh, there are some clouds, it means you will have rainfall. So how can you predict whether you will have rainfall? How can you give me a relative more specific measure of humidity? How can you say whether the air is saturated or not? So for this, a very innovative concept comes in hand. Innovative in the sense that this concept, if you understand, you will be easily able to guess whether you will have rainfall at a place or not. So how do rainfall occur? what are the conditions in which rainfall occurs, and what are the different forms of rainfall, different types of rainfall. That is what we are going to see today, because that is what is needed for your understanding of maps. So if I'm asking you, any one of you, those who are seeing me live or those who will see me in the future lectures, so if I'm asking you what are the preconditions for causing rain, or how can you cause rain, so your simple answer will be, sir, how can we cause rain if you think? So sir, if you have certain water vapor in the atmosphere, that water vapor should come down. The water vapor should condense and it should come down as rain. So I am asking you, okay, how come the water vapor will come down? How will the water vapor will come down on its own? And in what form, in what type it will come down? So now we need to think of a more explicit measure for doing all of this. And that explicit measure, guys, it is called as relative humidity. It is called as what? It is called as relative humidity. Now, what do you mean by relative humidity? This is very important, guys. Please understand this very, very properly. Okay, what do you mean by relative humidity? So, relative humidity is expressed as the amount of water vapor, in the air, upon the amount of water vapor in the air upon the moisture holding capacity of air, into 100%. This is called as what? This is called as relative humidity. What do you mean by relative humidity? Relative humidity is expressed as the amount of water vapor in the air upon the moisture holding capacity of air into 100%. Okay, so if I'm asking you that this is an air pocket, and if I'm asking you whether you will have rainfall from this air pocket or not, okay, so you will first ask me, sir, how much is the water vapor content in this? So let's say I'm holding a cup, okay, and that cup can hold 500 ml of water, and in that cup now you are pouring roughly 400 ml of water. Can the excess water come down as rain? Your answer will be no. Why? Because the moisture holding capacity of the cup is 500 ml, whereas it is saturated by only 400 ml of water. So you need to now understand that if the moisture holding capacity of the cup is 500 ml, we need to do what? We need to go a certain level above. So if we add 520 ml of water, then the excess water will come out of the cup. Then the excess water will spill out of the cup. So if you have a certain moisture holding capacity of air and you have so much saturation in the air where the moisture holding capacity is exceeding, then the excess water vapor will come down as rain. This is called as the true measure of relative humidity. This is where you understand whether you will have rainfall in the world or not. Okay, so amount of water vapor in the air upon the moisture holding capacity of air into 100%. So if I'm asking you guys that whether you will have rainfall in your area or not, so your answer should be, sir, do not look at the sky. Do not see how many clouds you're having. Don't say that the sky is clear so you won't have precipitation. Your one line answer should be, sir, let us first check the relative humidity. Why? What will the relative humidity paint you? Relative humidity will paint you the picture whether the air is saturated beyond its carrying capacity or not. Whether the air pocket can hold the moisture which is present at your latitudes. So if I take you towards equatorial areas, if I take you towards the tropical areas where you are having heavy amount of rainfall, where you have heavy saturation of water vapor, so if the air is saturated beyond 70%, beyond 80%, and if I'm saying you that you are in the equatorial areas, your answer will be yes, sir. You will have excess amount of rainfall in this area. Why? Because the relative humidity is more than 70%. So if I'm taking you to polar areas, if I'm taking you to tropical areas, extra tropical areas, or temperate areas where you know that you don't have that much amount of rainfall, but those areas are dry. Why? Because you are moving from equator towards the pole, so in general the temperature will decrease. So if the temperature is decreasing, you don't have that much vertical convection for air to rise up and condense. So even if you have air which is saturated more with water vapor, the excess will not come down. Why? Because those regions are those areas where the insolation is not that high. So, one line answer for you all to judge whether you will have rainfall at a particular place or not is going to be the percentage measure of relative humidity. What is relative humidity, guys? The amount of water vapor content in the air upon the moisture holding capacity of the air pocket into 100%. So, if you just do a Google search. If you just do a Google search of the weather conditions of any particular location, you can guess whether you will have rainfall or not. And hence, I will be doing a live Google search today wherein you and me will participate in this interactive exercise in determining whether you can have rainfall at a particular place or not. Okay, so let us first do the Google search of Singapore. Okay, let us first do a Google search of the weather of Singapore for you all. Okay. So if I'm just searching weather of Singapore, okay. If I'm just searching for you all the weather of Singapore, okay, where you understand the weather. So if you see this, conditions, okay. Okay. So if you see this, the weather of Singapore right now is 29 point or almost 29 degrees Celsius. The precipitation percentage is roughly 99.9%, and the humidity is just what, 77%, and the precipitation percentage is right now 9%. So if the humidity percentage is 77, what do you mean by this? That still air has roughly 25% in excess of its moisture holding capacity, in the sense of what, that air can still accommodate more 25% of water vapor for it to cause precipitation. Hence, the precipitation ratio or the precipitation index is less. It's barely 9%. Okay, so there are only 9% chances of you having rainfall in Singapore. Why this is so? Because the air is still not 100% saturated with water vapor. If this percentage increases, which is this humidity, guys, mind you, this humidity is relative humidity. This humidity is not absolute humidity. This humidity is not specific humidity. This humidity is relative humidity. And as I already told you, what do you mean by relative humidity? Relative humidity means that humidity wherein you express the amount of moisture present in the air as a percentage of the moisture holding capacity of air. So right now, if I'm taking you to Singapore, it's showing cloudy, it's showing precipitation, and the precipitation level or the precipitation chances are 9%. Why so? Because the relative humidity is still at 77%. So it will just take more 20 to 23 percentage of water vapor to flood the air to go or excess of the capacity of the air. And mind you, where is Singapore? Singapore is on the equator. And on the equator, every one of you know that you are having intense vertical convection. Why? Because on equator, you will have what? You will have direct perpendicular rays of the sun. Hence, the weather or the right now, the weather of Singapore is cloudy. So if I open up the precipitation map for you all of Singapore, so if I just click on the precipitation, so if you see the precipitation of Singapore, so right now, the precipitation between Okay, so if I go down, okay, if I open up today, Monday, so today if I'm showcasing you the precipitation map of Singapore, okay, so between 11 p.m. to 8 a.m. the percentage of precipitation or the chances of you getting rainfall is very less. It is between 9% to 13%. But as soon as you are moving from 11 a.m. to 2 a.m., how much chances of precipitation you are having? Roughly 65%. Okay, indicating what? Indicating what? That in the night time, the air of Singapore intends to have increased humidity. So as soon as your humidity increases, as soon as your humidity increases beyond a certain point, see how much are the chances of precipitation. The chances of precipitation are roughly 70%. So this is the correlation of relative humidity with precipitation. As soon as the relative humidity will increase, your chances of precipitation will also increase. Now, let us do a Google search of, let's say, Sahara. So let's move to Egypt. Let's do a Google search of the weather of Egypt. Okay, so I'm moving to the capital city of Cairo. So I'm just doing a plain simple reading of Cairo. Okay, so if you now see the weather of Cairo, okay, so now if you see the weather of Cairo, the weather of Cairo is roughly showcasing how much degrees Celsius? Only 26 degrees Celsius. Okay, the humidity is barely 35%. Why? Because where is Cairo? Cairo sits on the Tropic of Cancer, and as the relative humidity is so low, guys, what is the precipitation chances? The precipitation chances are completely 0.005, 10, 12%, indicating what? The air is not at all saturated with water vapor. And this is happening why, guys? Because all of you know that Cairo, Egypt, Sahara, they all sit on the subtropical high pressure belt. So because of this, you will have clear skies. Okay, because of this, the air will not rise up. Why? Because of high pressure conditions. Whereas on equator, exactly opposite was happening. And hence, on Cairo, because of such low relative humidity, the air is not yet saturated with water vapor, and hence the precipitation chances are almost zero. So this is how you can interpret the weather or the chances of rain occurring at any place. What you have to see first, the first point which you have to see is latitude. Second, you have to see how much is the relative humidity. As soon as you try to guess the latitude and the relative humidity, your chances of getting to know whether you will have precipitation or not will come out. I'm again reiterating. If I'm moving to Egypt, Egypt will sit on the Tropic of Cancer. As soon as you have the Tropic of Cancer, the first thing which will come to your mind, oh sir, this is subtropical high pressure belt. The air is subdued, there is no vertical convection. So it's very likely that you will have no clouds. So the air is not at all saturated with water vapor. The relative humidity is barely 35%. So will we have precipitation? Absolutely not. Hence, the precipitation at the Tropic of Cancer regions or at the desert conditions will be very, very low. Now, this is another example. Now, let us try to understand with regards to a coastal location. So, let's come back to India. Let us do analysis of weather of Mumbai. So, if I'm discussing with you all the weather of Mumbai, okay. So, Mumbai, you all know, is a coastal city. Mumbai, you all know, is a city which lies in the tropical areas. So now, if I'm discussing the weather of Mumbai for you all, okay. So right now the weather of Mumbai is around 32 degrees Celsius. Okay. The humidity is barely 66%. The humidity is barely 66%. And as you know, Mumbai is between the tropical areas and the equatorial areas. So, but naturally the sun is going to shine bright And as now the relative humidity is barely 66%, is the air saturated with water vapor? No. As the air is not saturated with water vapor, indicating what? The precipitation chances are very, very less. So the first thing which each and every one of you should understand, whether you will have rainfall in any region or not, whether you can have a good amount of distribution of rainfall pattern, the first thing which you need to understand is the latitude of that location. Second thing which you need to understand is how much air is saturated. So Mumbai, tropical to equatorial location, but naturally you will have high amount of evaporation, but at present the relative humidity is only 66%, indicating you can flood extra 30% of air and still you won't have rain, hence the precipitation chances are very, very less. So guys, this is how you need to move ahead with your understanding whether you will have rainfall at your location or not. So I am again reiterating guys, whether you can have rainfall in your location or not, it will be dependent on what? It will be dependent on number first, your latitude. Okay, your latitude, your understanding of whether this latitude represents heavy rainfall pattern or not. So if I'm considering equatorial areas, those areas will inherently be having high moisture vapor content. And the second thing which you need to understand is how much air is saturated, or what is the relative humidity. What is the relative humidity of the place? What is the relative humidity of the place? So if I'm showcasing you all on this on an atlas, okay, if I'm showcasing you all this on a map, so let us put down the Earth's map so that you understand this very, very beautifully, so that you get the concepts properly. So now let's zoom in. Okay, let's understand this. Okay, so if I'm considering the equatorial areas for you all, okay, these are our equatorial areas like this. Okay, so if we consider the equatorial areas for you all, okay, so equatorial areas, but naturally because of intense vertical convection, because of intense vertical convection will have what? They will have heavy saturation of air with water vapor. So because of this, now air starts to become saturated with water vapor. And number two, if the relative humidity goes beyond 80% and above, 80% and above, you will have 100% chance of precipitation. Okay, so whenever now you will see whether you will have rainfall in your location or not, whether you can have it or not, you will have to focus on this part. If I take you to the tropical areas, okay, if I take you to the tropical areas, again you will have to see what? Whether that latitude corresponds to high pressure condition or low pressure condition. This part will coincide with what? It will coincide with high pressure conditions. So but naturally you will have subdued evaporation. As the evaporation is subdued, the air cannot get condensed, the water vapor cannot get condensed. So but naturally the water vapor content in this parts of the globe is going to be less. And second thing, again, relative humidity. So if the relative humidity is, even though if it is extremely high, let's say it is around 85% or 90% guys, then also it's very difficult for you to have rainfall in these regions. It is very difficult for you all to have good rainfall pattern. Why? Because of the latitude of that place. And if we move ahead, if we move towards the temperate lands, towards the torrid land, again the same thing. And here guys, you will have to consider the local factors too. Local factors means, do you have mountain ranges which act as orographic barriers, which we did in the previous classes? Do you have grasslands? Do you have xerophytic vegetation? That all things. So this is the measure of relative humidity for you all to understand whether you can have rainfall in your area or not. So I have answered a very simple question, whether you can have rainfall in your area or not. Now let us move ahead our discussion and let us go into little bit of more technicality. Okay, so this technicality is, we got to know that, okay, a parameter which can guess whether you can have rainfall or not. But how does rainfall occur first? How rainfall forms, or how you can have rain in the air? What causes rain? So if a small 5-year kids come to you and ask, brother, sister, or elderly person, please tell me how this rain is falling down, or how are we having this? What you will answer? You will be at a point blank. We never thought how we'll be able to do this, or how the rainfall is actually coming. So you need to understand the natural phenomenon responsible for occurrence of rain. Whether rain will occur or not, we have already done on the measure of relative humidity. But how the rainfall is occurring, or what is the reason behind this occurrence, now let us try to understand that too. Okay, so if I'm making you understand whether the rainfall will occur or not, so you need to understand how rainfall actually occurs in the atmosphere, or how you actually have precipitation. Okay, so again I'm taking the example of a cup. So imagine I'm holding a cup which is having 500 ml of capacity. I am flooding it with only 450 ml. Will you have rain? No. If I am flooding it beyond its carrying capacity of 500 ml, will you have rain? Yes, you will have rain. So you have two options in the nature with regards to causing the rain. Number one, the first option where you can have rain, or how does rain occur? Okay, how does rain occur? So rain occur means what? How can you cause rain? How can you cause rain? So you can cause rain by, number one, by exceeding the moisture holding capacity of air, by exceeding the moisture holding capacity of air, the moisture holding capacity of air, the moisture holding capacity of air. Okay, how can you do this? How can you exceed the moisture holding capacity of air? Again, you can do this by two things. Number one, okay, you can physically add up the moisture. Number A, physical addition of moisture, physical addition of moisture. Or number two, how can you have rainfall? Okay, so my cup's quantity was 500 ml. I have physically added up the moisture beyond 500 ml. So I've added up 600 ml. So the extra 100 ml is coming down as rainfall. So physical addition of moisture. And number two, what I'm trying to do this, instead of physically adding up the moisture, I want rainfall. So what I will do, I will lessen the carrying capacity of the cup. I will do what? I will do something reverse. The Indian way called as jugaad. So we will do the reverse thing. Instead of physically adding up the moisture, we will try to reduce the carrying capacity of the air pocket. We will try to reduce the carrying capacity of the cup. So number two, you can reduce the carrying capacity of air. You can reduce the carrying capacity of air. You can reduce the carrying capacity of air. How can you reduce the carrying capacity of air? How can you reduce the carrying capacity of air? You can reduce the carrying capacity of air via condensation. Via condensation. What do you mean by condensation? So you are having an air pocket, you are moving up. As you are moving up in the troposphere, or in the lower layers of atmosphere, as we move up, the temperature falls. So as soon as the temperature falls, the air pocket will start condensing. And you all know, guys, that cold air will hold less amount of moisture as compared to warm air. So as soon as you start condensing the air pocket, the carrying capacity of the air pocket will reduce, it will fall. So even though we are having the same amount of moisture in the water vapor, if we start condensing the water vapor, if we start condensing the air pocket, so as soon as we start condensing the air pocket, its carrying capacity reduces, and you can have the excess water vapor coming down as rainfall. I'm again reiterating what you are trying to do. You are trying to reduce the carrying capacity of the air pocket. How can you reduce the carrying capacity of the air pocket? You can reduce this by condensing the air pocket. If you start condensing the air pocket, the moisture holding capacity of the air pocket will decrease, so that for the same amount of moisture, for the same amount of water vapor, you can have condensation. I'm again reiterating this. I'm again explaining this very properly using very crude diagrams. So just bear with me, guys. I know these aspects are a little bit technical. This is the last concept of climatology which I will be discussing with you all, because beyond this we'll be moving into the lithosphere. So please bear with me. The last topic of this part, then we are shifting our focus to the lithosphere. Ideally I should have started lithosphere today, but I thought that this is important because globally the climatic rainfall events have become very extreme, and the sea surface temperatures are now increasing, more and more water is being pumped. So this becomes necessary for you all to understand. So firstly, I made sure that you understand that what are the chances of precipitation, whether you will have rainfall in your area or not, that is being answered by the relative humidity. Now, how can you have this rainfall, or what causes the rainfall, that we are trying to guess. So number first option was you can physically add up the moisture, or second option was that for the same amount of moisture, if you reduce the moisture holding capacity of the air pocket, the excess moisture will come down as rain. So I'm using very crude diagrams, I'm using very crude analysis. So let us focus on that. Okay, so let's say I'm considering a cup A. So this is our cup A and this is our cup B. Okay, now each of them are holding, let's say, 400 ml of water. Okay, so this is 400 ml, this is also 400 ml. Okay, and the capacity of both of them is 500 ml. Okay, both of them is 500 ml. So this is the capacity. So if we want that the excess water of this cup should come down, so we should increase the 400 ml to at least 150 ml, or let's say even 110 ml, so that the excess 50 ml or the excess 10 ml will come down as rain, Okay, or what we can do, if we want to achieve rainfall from this particular cup or the excess water pillage, so we can do what? Instead of the capacity of 500 ml, we are reducing the capacity by, let's say, 150 ml. We are reducing the capacity by 150 ml, or we are reducing the capacity by roughly 120 ml. So if we reduce the capacity by 150 ml, what will happen? So 400 minus 150, the excess 50 ml will come down as rain. Okay, and here also the excess 20 ml will come down as rain. Why? Because you have reduced the carrying capacity. So now the carrying capacity is barely 250 ml. So 350 ml, the excess will come down as rainfall. So the same thing can happen with the air pocket. How can you do this? So if I'm considering an air pocket, if I consider an air pocket, okay, the capacity of this air pocket to carry moisture is roughly 500 ml. Okay, and you only have how much water vapor present in the air? Let's say you have only 400 ml of saturation. Okay, you are only having 400 ml of saturation. Now you want to achieve rainfall from this. How can you do this? Now you start condensing the air pocket. As you start condensing the air pocket, it cools down. As it cools, the carrying capacity decreases. As it cools, the carrying capacity starts to decrease. So instead of 500 ml, now the carrying capacity will only be how much? Let's say the carrying capacity is now only 300 ml. So the excess 100 ml will now come down. Okay, the excess 100 ml will now come down as rainfall. And guys, out of the two mechanisms which are discussed, okay, as to where you can have rainfall or not, okay. So out of these two mechanisms, where you physically add up the moisture or you reduce the carrying capacity of the air pocket, this is the more natural way of you having the rainfall, wherein as the air rises up, it cools down, and as it cools down, the excess water vapor will come down as rainfall. So both of the question answered, what are the chances and how will the rainfall form basically. So basically this is the concept of moisture, this is the concept of precipitation, and this is the concept of humidity. Now you can have different types of precipitation, different forms of precipitation, okay. So the water vapor can come down as rain, the water vapor can come down as snow, the water vapor can come down as rain, okay. The water vapor can come down as hailstone, can come down as hailstones, okay. The water vapor can come down as sleet, okay. What is sleet, guys? Sleet is called as freezing rain, okay. Sleet is called as freezing rain, okay. The water vapor or the water droplets or the rainwater droplets, before touching the ground, they start freezing in the atmosphere itself, so it is called as freezing rain. Or it can come down as glaze. Glaze is called as black ice, okay. So if you go to the upper reaches of Himalayas, you will see a very thin layer of ice on the surface of road as soon as the surface temperature drops below the freezing point, so you can also have glaze. So this is how in which the water vapor can come down. So you can have snow, you can have rain, you can have hailstorms, you can have sleet, and you can have glaze, okay. So guys, this information is very vital for us understanding the different aspects of world's physiography. So now let us try to paint a picture wherein I will be discussing where you can find these anomalies and what can be the moisture or the precipitation indexes of the world in general per se, okay. So if I consider the equatorial areas, I'm again doing the same. If I consider the equatorial areas, so in equatorial areas, your chances of precipitation will be extremely high, okay. If I move towards the tropical areas, your chances of precipitation will be extremely low, okay, extremely low, okay. If I move towards the temperate areas, on the western boundary regions where you have mountains, this part of, sorry, not in Australia, the last part is of New Zealand over here, very small part of New Zealand, this side, here you can have what, here you can have rainfall, okay. What kind of rainfall you can have? This part, I'm again reiterating, this part, and this part of New Zealand. How can you have rainfall in these parts of the world? Why? Because of the local orogeny. So here you will have predominantly water coming down as rain. If we go to the northwards of 66.5 degrees, to the northwards of Arctic Circle, predominantly the moisture in the air will be very less, the air is cold, okay. Whatever moisture you will have, it will come down as what? It will come down as snow. So as you increase with height, as your altitude increases, as your height starts to increase, what will happen? So if you are on ground level, you can have rainfall. As you move upwards, the rainfall decreases, and the upper reaches you will have snowfall. Why? Because all the moisture vapor is directly condensing into snow. So if I consider a mountain, on the lower reaches you will have rainfall. As you move upwards, the rainfall will decrease, and you reach to the summit, you will have snowfall. So the equatorial trend from equator towards the poles, you can see this on mountains. Hence the altitude mimics topography. I'm again reiterating, the altitude will mimic topography from equator towards the poles. If you are going on a high mountain, so the lower reaches will have rainfall. The middle reaches will have what? Less rainfall. You can have the grasslands, or you can have alpine meadows like the margs of Kashmir, Gulmarg, Sonmarg, Tunmarg. If you go above where the rainfall is extremely less, you can have snowfall, you can have permafrost, snow-capped mountain tops. So altitude will mimic topography, or the topography will mimic the altitude. Okay, so this is a very common understanding as to how you can have different types of precipitation globally. But mind you guys, there are certain exceptions. Okay, and I'm quoting this for the first time, that you can even have snowfall in desert. Sahara for the first time received snowfall in the months of January and February last year too, and in 2021 too. Okay, why did it receive snowfall, and in what time or in what time scale, or what were the reasons for that? That is your homework today. I will be discussing this in the next class, but very 2 or 3 minutes of discussion, then I will move towards the understanding of lithosphere of Earth, but that will be your homework for today. Okay, so here I am ending my lecture for you all today. So let us try to quickly revise whatever we did today. So we did two very important concepts today. The first important concept was that of moisture and humidity. So the moisture and humidity is basically the amount of water vapor content in the atmosphere. Humidity, you can express humidity in different forms: absolute humidity, specific humidity, but the true measure of humidity, it is called as relative humidity, wherein we discuss the amount of moisture in the air upon the moisture holding capacity of the air pocket as a percentage term. So you can predict whether you can have rainfall at your latitude or not. So if I'm asking you what is the precipitation chance at your latitude, you should first see on which latitude I'm talking about, and second you should see what is the relative humidity, because that will give you a measure as to how much the air pocket is saturated. So please make sure that you understand that too. Second thing, you all got to know whether today, like how rainfall forms or how rainfall falls, what are the occurrences of rainfall. So how the rainfall will occur when the moisture holding capacity of the air pocket is exceeded. So for this, you can either have physical addition of vapor, physical addition of moisture, or you can have what? For the same amount of moisture or the same amount of water vapor content, you reduce the temperature of the air pocket. So if you reduce this temperature of the air pocket, you start condensing it. So as soon as you start condensing it, its moisture holding capacity decreases. And so for the same amount of moisture, you can have precipitation. So these two very important things we did, and I discussed some of the temperature patterns globally. I just got some of the examples. So I hope this lecture was enlightening you all. I'm again reiterating, please work upon this concept and please join me on the Telegram channel called as Geography by Pritesh Maturkar. I daily post only one article or one PDF, not more than that. I'm not a faculty which will try to cringe in as much information as possible. And slowly guys, you and me will both move ahead. Okay, that's my promise to you, and that is how we will learn, you from me and me from you. Okay, so let's move ahead. Let's start our discussions on the lithosphere from the next class. And I'm again reiterating guys, you all need to have Orient Black Swan School Atlas 8th edition with you all. Okay, for joining this, you can just do a global search on Telegram at Geography by Pritesh, wherein I will post up all the relevant affair materials, and we all will learn from that. So thank you on the behalf of StudyIQ IAS English. I hope each and every one of you is having a pleasant time with me. See you all tomorrow sharp at 5 p.m. Bye bye. Take care. Work hard and smart.